Well, next question, another interesting one. Question number 2, there was on board. Have you completed it? Likha ache. So, erasing the diagram and the working portion of question number 2. So, now we are having question number 3 on board. That is again as per one VT graph. Initial velocity, yes, I have marked it as 8. Initial velocity I have marked as 8. That means initial velocity will be 1, which will be cutting y-axis. The point where the line will cut y-axis, that is the velocity axis, that will be the initial velocity. So, here in this case, the given information suggests u is equal to 8 meter per second. We do not know acceleration, but we know that one thing, that is something is visible from the diagram. If I take this is theta, then this much is 8 as per the scale suggesting here. This is 8, 0 to 8 second means 8, and this is also 8, right. So, from geometry, can I write down the numerical value of the tan theta that I have shown the theta position in geometry? So, according to this theta, tan theta will be 8 by 8, right? Tan theta will be, according to geometry, what we can see here, can we write down tan theta 8 by 8? So, 8 by 8 means it is 1. But is this value numerically got it as 1? Is it the acceleration here? No. Acceleration will be decided by always taking the angle which is appearing between the line and the positive direction of x-axis. Always note this thing, acceleration will be decided by the angle between the line drawn between the line and positive direction of x-axis. So, that is why the angle which is between the line and the positive direction of x-axis, that is not theta, rather that is the supplementary angle pi minus theta. So, therefore, I can write down the numerical value of acceleration what we need, that will be actually the numerical value of tan pi minus theta. Is that okay? Acceleration of a velocity time graph will not be known by any angle theta taken, rather it will be the angle appearing between the line and the positive direction of x-axis, that is positive direction of time axis, right. So, that will be tan pi minus theta, and we know that trigonometrically tan pi minus theta is basically minus tan theta. So, numerical value of 1, but minus 1 will be the value of acceleration. We have got the tan theta value as 1, we can use this result. So, minus 1 meter per second square is the acceleration. That means this time acceleration is negative. This implies that now acceleration is negative. So, under negative acceleration we can understand negative acceleration means force is working opposite to the motion. Okay. Negative acceleration means it is working opposite to motion. Right? Opposite to motion, and that's why velocity will decrease. You can see that with the increasing time coordinate, y coordinate is decreasing, right? This is the indication that velocity is decreasing with increasing time. Are you getting it or not? Tell me. Are you thorough with it? Siddharth, Tejas, Gauravi, fine. So according to the diagram where we can see the line cuts the x-axis at t equal to 8 second, that means we can add this observation that at t equal to 8 second velocity is 0, because the line cuts x-axis. I said that in the last question also, wherever the line will cut x-axis, that is the time axis, the axis representing time, the point where we can see the velocity time graph is cutting the time axis, means it is the moment when velocity value will be 0. So though it is starting with 8 meter per second, moving under the constant retardation of 1 meter per second square, so at t equal to 8 second its velocity becomes 0, right? And then after 8 second, up to 10 second, its velocity position, that is the y coordinate of the, if you see the y coordinate of a point in between t8 and 10, y coordinate is coming negative, right? So that means after 8 second velocity becomes negative. After 8 second velocity becomes negative. What does it mean saying velocity becomes negative? Means particle starts returning back. Suppose at t equal to 0, it had the starting velocity of 8 meter per second in this direction. So from the beginning acceleration is working against the motion. So particle still continuing moving forward. This is the instant t equal to 8 second. Here particle's velocity becomes 0, but still acceleration is alive. Still acceleration is available on it, and that's why now the particle first going forward and then it is bound to return back, because the backward acceleration now enforce the particle to return back. Are you getting me or not? If this is the starting instant, let this is the instant position B where its velocity turns to be 0, but the particle doesn't remains at rest after reaching B, rather after 8 second, suppose at t equal to 10 second, the particle has traveled some more distance moving backward. Okay, so whenever velocity will be negative, that means we can write down after 8 second, after t equal to 8 second, particle starts returning backward. Got my point? The particle starts returning backward due to constant retardation or negative acceleration. The negative acceleration is only called retardation also. Are you understanding it? So after 8 second, particle is bound to return back, going backward to, that is returning back to the starting point. So I asked about the velocity value at 10 second. So being it is continued with the same magnitude of acceleration, that's why numerically this theta and this theta will remain same. Therefore, if I assume the velocity value something negative at t equal to 10 second, so I can say this part V and this part of the interval from 8 second to 10 second, interval is 2 second. So therefore, we can write down tan theta can be written V by 2, right? For this last right angle triangle geometry which is appearing below the time axis. Are you understanding it? Because the tan theta calculation that we got in this right angle triangle, that one will be same in this right angle triangle also. Okay, so here we can write down numerical value of tan theta was 1, that is V by 2. So this implies that V is magnitudically 2, but being it is being it is hitting the negative portion, so therefore we will say velocity is minus 2 meter per second at t equal to 10 second. Are you getting me? At t equal to 10 second, velocity value is minus 2 meter per second. Are you getting this solution? Tell me, are you thorough with it? বুঝতে পারছো কোথাও আটকাচ্ছে কিছু? Very good. So see, on one straight line graph which is following the general straight line equation on xy plane, we can talk about so many terms, so many concepts in physics. Now I asked one more question. I asked that, is this particle is having equal measurement of displacement and distance during this journey? So answer will be yes or no. Is it going under equal value of displacement and distance traveled? Who will give me the answer? Who will give me the answer of the last part? Isn't it? There was a third part of this question where I have asked, is it going equal displacement or and distance traveled? Siddharth saying no. Siddharth, can you give me the reason why displacement and distance measure don't be same? Can you elaborate it? লিখেছো পুরোটা? Keep writing. বোঝার সাথে সাথে লিখতে হবে, নাহলে কখন আমি ভুলে গিয়ে মুছে দেবো। লেখা হয়েছে পুরোটা? ওকে। So who can give me? Siddharth, can you elaborate why you are saying that displacement and distance traveled won't be equal? See, I can say that from t equal to 0 to t equal to 8 second, particle is moving forward. Suppose this is A, this is B, let this point is C. Okay, position wise, particle is traveling forward from A to B, and then from t equal to 8 second to t equal to 10 second, it is moving backward. From t equal to 8 second to t equal to 10 second, it is moving backward. That means displacement will be equal to A to C, right? And distance will be equal to AB plus BC. So either one is going forward or coming backward, the total path length, the distance is equal to total path length, the total path traveled by the particle. The particle is first traveling A to B, which is the forward direction motion, then during the last 2 seconds it is also traveling, but it is traveling backward. Okay, so that's why total path length will be AB plus BC, right? And displacement will be only A to C. Displacement is the separation between initial to final position of a journey. So obviously here we can write down displacement is less than distance. Displacement is less than distance traveled, right?